Observability and SRE Part 4. This episode has 23 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Similar scenario. Today interview July 6, 2026. Similar scenario progressive mitigation. A bad release affects only 10% of users. How would you decide between rollback, canary pause, feature disablement, and traffic shifting? Here's a strong way to approach it. First, freeze rollout and stop increasing exposure. If the issue maps to a feature flag, disable the feature because that is usually fastest and least disruptive. If the canary version is bad, roll it back or shift traffic back to the stable version. If only one region or cluster is affected, shift traffic to healthy capacity if available. Roll forward only if the fix is small, already tested, and faster than rollback. Validate recovery on user impact metrics, not only pod health. Nice. Let's continue. Question 2. Datadog or observability. How would you install and configure the Datadog agent on a Kubernetes or GKE cluster? Here's a strong way to approach it. Install the Datadog agent as a daemon set, usually with the Datadog Helm chart or operator, so every node runs an agent pod. Store the API key in a Kubernetes secret. Set the cluster name and tags. Enable kubestate metrics or core DNS or node or container collection, and turn on logs, APM, process, or network monitoring only when needed. In GKE, also configure the GCP integration for cloud-level metrics and use tolerations so the agent runs on important node pools. Great. Moving on. Question 3. Datadog or observability. How does Datadog collect metrics, logs, and traces from Kubernetes workloads? Here's a strong way to approach it. Datadog collects node and container metrics through the agent, cluster object state through kubestate metrics or the cluster agent, logs from container st.out or st.var or files, and traces through APM libraries sending spans to the agent. Kubernetes labels, annotations, pod metadata, service names, environment, and version tags are attached so metrics, logs, and traces can be filtered and correlated by service, namespace, cluster, and deployment version. Alright, next question. Question 4. Datadog or APM. How would you enable Datadog APM for a microservice running on Kubernetes? Here's a strong way to approach it. Add the Datadog tracing library for the application language, set service, env, and version tags, and point the app to the Datadog agent trace endpoint. In Kubernetes, expose the agent APM port, inject environment variables through the deployment, and verify traces appear with correct service names, resources, errors, latency, and dependencies. For production, configure sampling, sensitive data scrubbing, and trace log correlation. Let's keep going. Question 5. Datadog or logs. How would you correlate Datadog logs with traces for faster debugging? Here's a strong way to approach it. Enable trace log correlation in the Datadog tracing library so traceID and spanID are injected into structured application logs. Ship logs with the Datadog agent, parse them as JSON where possible, and standardize tags like service, env, version, cluster, namespace, and pod. Then an engineer can jump from a slow trace to the exact related log lines, or from an error log to the full request trace. On to the next one. Question 6. Datadog or monitoring. What Datadog monitors would you create for a production API? Here's a strong way to approach it. Create monitors for user-impacting golden signals first. Availability, 5xx error rate, page 95 or page 99 latency, request rate anomalies, saturation, and dependency failures. Add Kubernetes monitors for crash loop backoff, pending pods, restart spikes, CPU or memory pressure, HPA maxed out, node readiness, and ingress or load balancer errors. Alerts should have owners, severity, routing, runbooks, dashboard links, and thresholds tied to slows rather than every noisy metric. Good. Here's another one. Question 7. Datadog or SRE. How would you define slows and error budget alerts in Datadog? Here's a strong way to approach it. Define SLEs from request success rate, latency, or availability using Datadog APM, metrics, or logs. Set slow targets such as 99.9% successful requests over 30 days. Then create burn rate alerts for fast burns and slow burns so teams catch both major outages and gradual degradation. Tie alerts to service ownership, on-call routing, release policy, and error budget decisions. Nice. Let's continue. Question 8. Datadog or dashboards? What dashboards would you build in Datadog for application teams, SREs, and leadership? Here's a strong way to approach it. For application teams, build service dashboards with red metrics, dependency latency, error traces, recent deployments, and logs. For SREs, build platform dashboards covering clusters, nodes, workloads, ingress, slow burn, incidents, and capacity. For leadership, show availability, customer impacting incidents, slow compliance, MTTR, change failure rate, and cost or reliability trends without overwhelming low-level details. Great. Moving on. Question 9. Datadog or incident response? A Datadog alert shows page 95 latency increased after a deployment. How would you investigate? Here's a strong way to approach it. Start from the alert timeframe and compare latency by service, endpoint, env, version, region, and deployment marker. Use APM traces to identify the slow span. Check errors and logs correlated to those traces. Then inspect dependencies such as database, cache, downstream APIs, and Kubernetes resource saturation. If the new version is the clear trigger and user impact is high, pause rollout or roll back while continuing root cause analysis. Alright, next question. Question 10. Datadog or cost? How would you control Datadog cost for logs, custom metrics, and high cardinality tags? Here's a strong way to approach it. Control cost by reducing noisy log ingestion, using exclusion filters, sampling debug logs, setting retention by value, and indexing only logs needed for search or alerting. Avoid high cardinality tags such as request IDs, user IDs, pod UIDs, or unbounded URLs on custom metrics. Review custom metric volume, container counts, APM ingestion, and dashboard or monitor usage regularly with ownership and cleanup policies. Let's keep going. Question 11. Datadog or synthetics? When would you use Datadog synthetic monitoring and real user monitoring? Here's a strong way to approach it. Use synthetic monitoring to test critical user journeys or APIs from controlled locations on a schedule, even when real traffic is low. Use real user monitoring to understand actual browser or mobile user experience, front-end errors, page load time, geographic latency, and the impact of releases on real customers. Together they help distinguish external availability from real user experience. On to the next one. Question 12. Datadog or integrations? How would you integrate Datadog with GCP, Slack, PagerDuty, and CI or CD pipelines? Here's a strong way to approach it. Use the GCP integration to collect cloud monitoring metrics, audit logs, and service-level telemetry. Then tag resources consistently by project, environment, team, and service. Route Datadog monitors to Slack for visibility and PagerDuty for actionable incidents. In CI or CD, send deployment events and version tags to Datadog so dashboards and APM can correlate regressions with releases. Good. Here's another one. Question 13. Datadog or security? What security and access controls would you apply in Datadog for a large engineering organization? Here's a strong way to approach it. Use SSO or SAML, SIM provisioning, MFA, role-based access control, teams, restricted API or application keys, and least privilege permissions for dashboards, monitors, logs, and security products. Protect sensitive logs with scrubbing and pipelines. Limit who can create high-cost ingestion patterns. Audit changes to monitors and integrations, and separate production access from lower environments where needed. Nice. Let's continue. Question 14. GCP support. Starting point. Staying on GCP support when a production issue hits networking, storage, or security. What is your usual step-by-step approach to isolate whether it is a platform problem, an application problem, or something in IAM or VPC configuration? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Great, moving on. Question 15. Observability. What alerts or dashboards have you personally built or tuned? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Alright, next question. Question 16. Observability or incident. Can you walk me through one case where the alert fired but the real issue was something different from what the metric suggested? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Let's keep going. Question 17. GKE or Kubernetes. Walk me through a production Kubernetes issue you handled where a pod or deployment was failing. Tell me exactly how you diagnosed it from the first symptom to the fix. We don't have a model answer recorded for that one yet, so it's a good one to research on your own. On to the next one. Question 18. Terraform or GCP. What have you actually built with Terraform and GCP? Can you walk me through a real module or stack you owned end to end? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Good, here's another one. Question 19. IAM or security. In a GCP environment, how have you designed IAM or VPC security so that teams could move fast without opening things up too much? What trade-off did you have to make? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Nice, let's continue. Question 20. Production outage. Tell me about a production outage you worked on. What was the root cause? What did you change afterward to prevent it from happening again? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Great, moving on. Question 21. GCP incident or RCA. Pick one actual incident you handled in GCP. Walk me through the exact failure, how you found the root cause, and what the post-incident change was. We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Alright, next question. Question 22. Kubernetes networking. How would you troubleshoot Kubernetes networking issues involving CNI, services, and ingress? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Let's keep going. Question 23. Docker internals. Explain Docker internals that matter during production troubleshooting. We don't have a model answer recorded for that one yet, so it's a good one to research on your own. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.